Okay, all right. So today we are doing the last 2 days of videos, at least, because I think there's one day left right before the day of the region. So I might just use that day as a review, but not in a video format. Okay. So, all right. So in this last two lessons, the first part, all right, which we're going to do today are called step functions, which means like exactly what they look like. What happens when a function looks like a staircase? Okay. So there's a reason that it would look like that. And then the second thing is tomorrow we're going to do piecewise functions, which is what happens when you put different pieces of different types of function together on the same graph, all right? Which is kind of crazy. So let's start with the first part, and so let's go. Now write this down, okay? So we're talking about step and piecewise functions, so write that down, all right? This is what we're going to be doing in the next 2 days, all right? So now let's see. Let me make sure I'm recording. All right, good. Okay, now let's see. Here we go. Okay, now what's a step function? All right, I'll give it to you. I'll give the definition to you as simply as possible. All right, a step function is a piecewise function. Okay, I'm changing the order. Okay, because this is easier than tomorrow's. Okay, with many sub functions, meaning a bunch of little functions that resemble stair steps. Okay, that's it. So a step function is a function, right, with a lot of little functions underneath it. Okay, think of it like that. So for example, all right, let's use a different color. For example then, right, if you look at this first one, right, now look at this first. Look at the domain. So this set of rules, this set of functions is very domain specific. What do I mean by that, right? Domain means the x value, right? And specific means like it points to like, hey, where exactly are your x values gonna be coming from, and what are the boundaries set on those values? Okay, so for example, I'll color code this. All right, hopefully I won't run out of colors. I will run out of colors. Now, for example, for the first one, right? You see how it's the domain, the x value is between 5 and 7. Look, between 5 and 7. Right? The value of y is 1. Y is 1. That's it. All right. Now, have you noticed this is open and that's closed? Right? Why is that? Look at this. Look at this for the clue. Yeah, have you noticed? Right here. Have you noticed right here? This right here, this symbol right here, there's no line underneath, not inclusive. All right, you see that? So that's why. Okay, now I would think just by looking at this right now, as the teacher, as your teacher, that that I think the difficulty is getting used to the notation and the fact that you have a graph that is non-continuous at so many parts. I really think that is. I think the concept itself isn't difficult. There's not a lot of math that you have to, quote unquote, do. There's nothing to solve per se, but you're right now we're trying to communicate between the graph and the notation. All right, I want to put you in that setting. Okay, that's the perspective that we're dealing with here. All right, now that said, so for example, for this one from 7 to 9, right, which is 7 to 9. Right, the value is 2, and as you can see, it's 2. That's it. All right, and again, the 7's open, the 9's closed. Right, that's why 1's an open circle, 1's not. Okay, nothing new here, right? And then next one, right, from 9 to 11, right, the value is 3, again, open, close, right, because there's no line underneath here, and then so on and so forth. From 11 to 13, right, value is 4. From 11 to 13, value is 4. And then lastly, coming back, right, from 13 to 15, 13 to 15, the value is 5. That's it. Yeah, okay. So if you know how to read that, all right, and hopefully you will after today, then that's pretty much it. Okay, now let's look at some word problems, and then I just want to show you this. I don't even want to spend that much time on it. All right, I'd rather look at the I would rather look at the Regents questions, okay? And I don't want to spend more than 10 minutes on this, which is not possible, all right? We're already 5 minutes. Okay, so let's read this together. Get my highlighter. All right, so let's see. You want to bring cupcakes to the math club to celebrate your birthday, all right? Each box of cupcake contains 6 cupcakes, cost $4. There are as many as 30 students to be at the math club, right? Now, the math is very straightforward, but I think one of the things you need to understand is if you see the answer, you know what they're trying to say. So you have to conceptualize it like this, right? You have a box of cupcakes. They only sell it by box, right? So you can't get half a box, right? So you have to think how many boxes you have to get, right? For 30 students, right? So that's why I'm drawing this right now, okay, as I'm talking. So this is already 18. That's 24. That's 30. Nice round number, right? 5 boxes. So how would this be explained, right? How do you write that? Okay, because you guys all understand the problem. You know what I'm saying? Like, and each one of them costs $4, right? So that's $4. That's $4. That's $4. That's $4. That's $4. Right? That's all, right? So how do you conceptualize that? Simple. That's it. You write like this. Okay, right? So the cupcake, right, now again, the functional notation here is written very well here, right? Hold on. Right, so the function, right, is right here, right? Let's see, the cost, right, in terms of the number of students, right? So cost as a function of students, right? So again, the way you write it is, right, from 0 to 6 people, right, which accounts for these 6 cupcakes here. This would cost you $4. From the 7th to the 12th student, meaning 7, 8, 9, 10, 11, 12, it'll cost you $8 to buy, right? And so on and so forth. That's it, all right? Now, some of you might say, well, how do I determine these intervals, right, between 0 and 6? How do you know it's 0 and 6? 6 cupcakes a box, right? It's a unit rate, think of it like that, okay, right? Okay, all right, good. Now, let's take a look at some Regents questions then, and then we'll be done, okay? All right, let's see. Let's try one then, even though I don't have enough space. I gotta make this smaller. Hold on one second. But then again, I'm worried that if I made it too small, you can't read this. All right, let's try it. All right, let's see. Morgan can start wrestling at age 5 in Division 1. Hold on, getting my highlighter. All right. Age 5. Okay, I'm keeping that in mind. That's a clue, because look at the choices, right? All starts at 5. Right? Now, what else? He remains in that division until his next odd birthday, all right, when he's required to move to the next division. Okay, which graph correctly represents this information? Okay, all right. Now, let's see. Now, interesting, right? Not that much math involved in the descriptions. I don't know if you realize that. Hold on. Not that much math in the description. It's nothing. It's not like we have to hold on to every single clue. It's just like the next odd number birthday, right? So which one is true now? Well, let's try to distinguish between the 4. Okay. Based on what you've seen so far alone, right? What do you think would be the answer? All right, look back. I'll give you a clue. Look back at this one. Right? Now, here's the thing. Should we include, so what I'm trying to say is this. Should it be 1? Or should it be choice 2? Because have you noticed between 3 and 4, these are all closed and then these are all open, right? Think about that, all right? Let me let you think about that for a second. All right, what do you guys think? Is it choice 1 or 2? Now, I know what you're thinking. You're referring back to this, right? But you got to understand how, like, the difference between this is that there's an open, these are all started off with open circles, open values, right? Whereas, you know, for 1 and 2, right? The first one is an open circle. For number 2 is the first one. Oh, no, the first one's a closed circle. This is an open circle. So you might be inclined to pick this one. All right, it's actually choice 1, right? Why is that? Yeah, you could start wrestling at age 5. You have to include 5. And by the time he turns 7, has to be open circle because he's eligible for the next division. And then so on, so forth. Okay, now you might say, well, Mr. Ring, but the first one was open circle. Like, yeah, but the thing is, you gotta understand, there's no context to this, right? Like, there's no story behind it, so you don't even know what they're trying to say here. Do you understand? So you can't just, like, you know, blindly follow it, right? With no context whatsoever. Okay, got that? All right. Now, what's another good thing to show you? You know what? Yeah, try this one right now, and then I can just show you the answer key for this. Okay. All right. Okay. So try now. I just want to see if they're labeled. Yeah, they are labeled. So what should I do? You know what? Let's make this in 2 parts. So read the question, and then if you want to make the graph. Okay. So hold on. Let's see. Let's read this first. All right. How are we doing on time? Yeah, we're okay. We're okay. All right, we're gonna be okay. All right. So look, the table below sits the total cost of parking for a period of time in the street in Albany. The total cost of time up to and including. Okay, hold on. This is actually key. The total cost for any length is for any time up to and including the hours parked. So that's kind of telling you what to do with the circles. Like, is it going to be open or closed? Okay, right? Up to and including the hours parked. So let's see. For example, parking for up to and including an hour. Use a different color. Up to an hour would cost $1.25, and then 3.5 hours would cost $5.75. Right? So they gave us the example. Up to 3.5 hours. So meaning, like, you can't have half. Oh, by the way. So one of the things actually I want to talk to you about is why this would be the case and why the graphs look like they're steps. So in other words, why are they not continuous? Why are they discrete? Okay, so now should I explain this now? I should explain this now because you guys have to graph it. It's because it's not continuous. Like, so what they're saying, even with the cupcake one, you know how I said you can't break the boxes up in half and try to just, you know, feed a certain amount of people, right? It's because you can only buy it by the box. Therefore, the graph is a list of steps. It's not continuous. You can't buy like 3.5 boxes. They're simply not gonna do that for you. Think of it like that. Okay, that's why it's not continuous. Okay, all right. Now, so that means for something like 3.5. For something like 3.5, which fits between 3 and 4, right? 3 hours and 4 hours, you would still have to use this figure. So basically what they're saying is this is gonna be a step function. And not only that, they told you to graph the step function, okay? So now, I'm gonna lower this up, down a little bit so that you can see the table. Uh-oh. All right, let's see, what's the best way for me to show you this? Let's do it like this. Nope, still not good enough. I can't believe this. All right, hold on. So, okay, you know what? Here's what you do. Set up its graph, all right, using total cost as the y-axis and hours parked as the x-axis, all right? And then let's see what the directions are. All right, now I'm gonna look at that. All right, so try to graph this right now, and when you come back, I'll have the graph answer key for you. Okay, so press pause right now. All right, and we're back. So here's the graph. All right, that's it. Let's see, what else do I have to add? Not much. Okay, all right. Well, that's that. I'm gonna sign off here. Tomorrow, last video lesson of the year. Okay, and where we're gonna talk about piecewise functions. Okay, so we're almost there. All right. Thanks for watching. Have a good day. I'll see you tomorrow. Okay. All right. Bye-bye. OMG, that was so good.